Okay, I just want to go through briefly explaining how we can use the cathode ray oscilloscope to measure the peak-to-peak amplitude of a signal that we might get, like this one from our Search Coil. Now you can see that we've got an oscillating signal there. The oscillating signal isn't all that large, and so the first thing I'm going to do is I'm going to change the potential difference sensitivity. If I make that bigger, I can make that signal bigger. If I make it too big, it doesn't display on the screen. So I'm going to move it to that position there, which is where I've got the largest display without it going off the edge of the screen. Now, if you look at this one at the moment, it's reasonably well centered on the horizontal center of the display along there. But I want to measure the peak-to-peak potential difference as accurately as I can. So the first thing I'm going to do is I'm going to use the position control, the vertical position control, to move it so that the bottom of one of the oscillations down here, along there, is lined up as well as I can with one of the solid lines on the screen. Okay, something like that. So now I can try to use the vertical scale to measure the maximum height of that. Now, as you can see over here, these oscillations here haven't been quite aligned well with the central axis there. So I'm now going to use the horizontal position. I can move that to the left and to the right. And if I move it like that, then you can see that the bottom is lined up with one of the lines there, and the top is lined up with that central scale. So now what we can do is count the major divisions. That's 1, 2, 3, 4, 5, 5.5 major divisions. If I look at the display on my oscilloscope, I can see that I've got 5 millivolts per division, so each one of those is representing 5 millivolts. So that's given me a value of about 27.5 millivolts for that peak-to-peak potential difference.